Today's topic is equivalent fractions. Students have been looking at fractions that have like denominators and some that have unlike denominators. So if we're looking at the fractions that have like denominators, an example would be 2/4, let's say, and 3/4. So it would be pretty easy to figure out which fraction is bigger. In the beginning, students have used visual aids such as these fraction pies, and you could, if there was one that was fourths here, you could see that 2/4 was smaller than 3/4. Or in an example like this one here, let's say 2/6 and 4/6, students could see that 2/6 over here is smaller than 4/6. So looking at fractions with like denominators was something that students should have a pretty good grasp on by now. And what we're moving to is looking at fractions with unlike denominators. And that's a little bit more difficult to do in the abstract. So if we're looking at, let's say, 1/5 and 1/6, we have fifths up here and sixths. So if we're looking at what's bigger, 1/5 or 1/6, well, if we're using the visual aid, we can look and see, actually that 1/6 is smaller than 1/5. But if we eliminate the visual aids and students are just presented with these two fractions and they're asked, which one is bigger or smaller, how are we going to do that when we have unlike denominators? The idea then would be to convert the fraction so they have like denominators, which would make it a lot easier. So instead of comparing apples to oranges, which it looks like here, we'll try to compare apples to apples. So how do we do that? Let's see how we can make these the same. We need to think about what number goes into these that is divisible by both of these. So in the case of 5 and 6, the smallest number we would be thinking about would be 30, because 5 goes into 30 6 times, and 6 goes into 30 5 times. So that would mean that we'd have numerators that are denominators that are 30 and 30. And as we've learned, when you multiply a fraction at the bottom, you do this, you multiply the same at the top. So then this fraction becomes 6/30, and we're multiplying by 5 there, so we multiply by 5 here, and this fraction becomes 5/30. So now it's a lot easier to compare these two fractions. Which is bigger, 5/30 or 6/30? Okay, obviously, it's a little bit easier to realize that there's 6 pieces is bigger than 5 pieces. So that's one thing that we've been looking at. Another thing is to recognize equivalent fractions in patterns. So if I'm taking a fraction like, let's say, 1/4, and they're asked to figure out what the next, say, 3 are in the pattern, we can visualize, hopefully, that what the next fraction is from 1/4. And if we multiply both sides by 2, the top and the bottom, I should say, then we get 2/8. And then we can start to see a pattern emerge here. So 1, 2, 3 would be, and this one looks to be counting by 4, so 4, 8, 12. And then the next fraction would be 1, 2, 3, 4/16. And the point being that they're all the same, they're all equivalents, they're all similar amounts, they're all the same amounts of the whole. Okay, so that's another thing that we've been looking at, is recognizing equivalent fractions and patterns instead of using the multiplication method. Another one that we've been using or students have been presented with problems like this. 2/5 is the same as what over 15 is the same as what over over 30. Over 30, so equals and equals. So again, we have unlike denominators, so how are we going to tell that they're equivalent fractions, or how are we going to know that we've made equivalent fractions? Well, again, multiplication and division are going to help us out at the bottom here. And we have to see what number would be divisible into all of these. And in this case, we have a denominator that goes into 30. 5 goes into 30 6 times. And it also goes into 15. So we could just say 5 times 3, 2 times 3, and equals 6 over 15. And we could also say that 15 goes into 30 twice. So 15 times 2, and 6 times 2 is 12. So we have 12 over 30. So such questions as that we've been working on as well. And the last part to really think about is how to apply this in the real world to real problems. So the problems of the week and other problems that we've been working on in class have been doing exactly that. We're trying to take our knowledge of equivalent fractions and apply them to real problems and know what to do when we see those kinds of problems, especially when we see problems that have fractions that have unlike denominators, and what to do about that.